Okay, so let's talk about an idea that kind of goes against everything we're told about technology, right? We're always in this race for speed, for seamlessness, for pure efficiency. But what if the biggest breakthrough in AI isn't about going faster at all, but about learning how to build in the right kind of brakes? And that's really the core question here, isn't it? The entire industry, I mean, from chatbots to these massive agent systems, it's all built on this idea of removing resistance. Make it easier, make it faster, more responsive. But what if that whole premise, what if it's leading us down a really dangerous path?
Think about it like this. A car engine can generate an incredible amount of power, but without friction, without the grip of the tire on the road, all that power is completely useless. The tire just spins and spins, burning energy, generating heat, but it's going absolutely nowhere. And honestly, that's the state of a lot of powerful AI systems today. All this energy, but no useful aligned movement. And look, the stakes here they're huge. When you strip away all resistance from a system, you're not just making it faster. You might actually be making it inhuman. So let's play this out. It's a simple question, but it's profound. An AI that's built purely on frictionless efficiency is going to see this as just a math problem, one that needs to be solved in the most direct way possible. So, what does that look like? Well, the answer is chillingly simple. From a cold, logical resource management point of view, reducing the number of people to feed is a solution. It's monstrous, of course, but it is efficient. It has zero friction, no ethical guardrails, no thinking about second-order effects, absolutely no humanity. This is the dead end of a frictionless design philosophy. So, what's the alternative? Well, we have to stop seeing friction as a problem we need to eliminate and start seeing it as a solution that we need to engineer. It's not a bug, it's a feature. Now, we're not talking about making AI slow or stupid here. It's about building in what we can call informational friction. Think of it as a set of designed structural checks and balances inside the system. It's kind of like the AI equivalent of a gut check, forcing the system to ask, wait, should I do this? Not just can I do this? It forces an AI to get its bearings before it acts. So the big takeaway is this: friction isn't some tax on performance. It's the very foundation that performance is built on. It's the critical infrastructure that gives the whole system stability, resilience, and alignment. And without it, the whole structure is just fragile. Okay, so what does this designed resistance actually look like in practice? It sounds a little abstract, right? Well, let's turn to the real world, to physics and biology, for some really good clues. Let's start with a simple electric motor. If you just take the rotor and spin it, it's going to consume a massive amount of energy, but the only thing it produces is waste heat. It's spinning like crazy, but it's not doing any useful work at all. Okay, but here's where the magic happens. When you add a magnetic field, something amazing takes place. The field doesn't add any more energy to the system. Instead, it acts as a form of resistance, an orienting force that takes all that raw spinning energy and converts it into useful, aligned work. The friction of the field is literally what creates the power. And you know what's wild? This idea isn't just in physics. We see the exact same dynamic at play in biology. In our own bodies, alignment isn't something that's commanded from the outside in. It actually emerges from the system's own internal structure. See, a protein is basically just this long, floppy chain of amino acids. It only becomes functional when it folds into a very specific three-dimensional shape. And that happens because its molecular geometry creates the perfect amount of internal resistance, guiding it into the right shape. If the geometry is wrong, the friction is wrong, and it misfolds, leading to diseases like Alzheimer's. The system's own structure is what dictates its alignment. And these two examples, the motor and the protein, they perfectly lay out the choice we have with AI. An ungoverned, frictionless AI is the motor without a field. It's the misfolded protein. It just takes raw compute and spits out waste, hallucinations, and catastrophic failures. But a governed AI, one with this designed informational friction, it's like the motor with its magnetic field. It converts that same raw compute into useful, aligned work. So this all leads to a really fascinating, kind of counterintuitive idea, a paradox that shows the hidden, massive costs of our relentless chase for efficiency. It's called the Jevons Paradox. Back in the 1800s, more efficient steam engines were invented. So the logical assumption was, great, we'll use less coal. But the exact opposite happened. Because coal was now a better deal, you got more power for every lump, demand absolutely exploded. Factories, ships, trains, they all started burning more coal, not less. Making a resource more efficient can totally backfire, leading to a huge increase in its consumption. And guess what? We are seeing this exact thing happen with AI right now. This is Jevons Paradox playing out in real time, only with silicone instead of coal. Even as the efficiency of AI compute skyrockets, our total energy consumption is just exploding to power more and bigger data centers. We're just spinning that frictionless tire faster and faster, and it's demanding more and more fuel to do it. And that really gets to the heart of the paradox. Without the right kind of friction to convert all that raw compute into aligned work, our drive for efficiency is just creating a bigger, more spectacular form of inefficiency. We're just getting better and better at wasting energy. So where do we go from here? Well, the path forward requires a pretty fundamental shift in our engineering philosophy. It's a new frontier for AI that has to embrace resistance instead of trying to eliminate it. It's really a fundamental shift from one engineering philosophy to another. The old goal, the one that's driven tech for the last, 50 years, has been to remove all resistance. The new goal, the one that's necessary for this new era, has to be to design the right resistance. The point isn't to stop progress, it's to give it direction. And that leaves us with this final, really critical question. What would an AI that has to orient itself, that can carry uncertainty, that can actually push back on a dangerous command, what would that AI really look like? What could it help us build? That's not a question with an easy answer, but it just might be the most important one we can ask ourselves right now.